With this lesson today, we're going to talk about exponents and division, and we need to keep in mind the same thing when we talked about with exponents and multiplication. We're going to be dividing powers with the same base. The rule for dividing with exponents is if you want to divide non-zero numbers or variables with the same non-zero base, this time we're going to subtract the exponents. Okay, let's look at the example that you have on your notes. We have 7 to the 5th power divided by 7 to the 3rd power. And I've written that out so that you can see how many 7s are in the numerator and how many 7s are in the denominator. In order to see how many 7s will be left, we're going to match them up and cross them out because 7 divided by 7 is 1, 7 divided by 7 is 1, 7 divided by 7 is 1. And now I have no more 7s in the denominator, so my answer to this problem is 7 squared. So what we're actually doing is we're taking 5 minus 3 in the exponents and coming up with our answer of 7 squared. Okay, look at the first example. We have 4 to the 7th power divided by 4 to the 5th power. So we subtract those two exponents and we get 4 squared. We have another example, m to the 12th power divided by m to the 5th power. Well, subtract those exponents and you're going to get m to the 7th power. And then our last example, we have 6 to the 3rd power over 6 to the 7th power. This time when we subtract, we have 6, 3 minus 7. We're actually going to get a negative exponent of 6 to the negative 4th power. Okay, one more thing we need to talk about is when we see exponents to the 0 power. And what I'm going to show to you is how we actually get the answer, what a number to 0 power or a variable to 0 power. As you can tell, I have in this example 3 to the 5th power divided by 3 to the 5th power. Well, if you break that out, all of these match up. 3 divided by 3 is 1, 3 divided by 3 is 1, and it continues on down the line. So we end up with 3 to the 0 power because we subtract our exponents, and anything to a 0 power is 1. And if you look at the bottom of your page, you will see I have negative 9 to the 0 power. That equals 1. I have x to the 0 power. That equals 1. But look at the last one. I have, well, the next to the last one, I actually have it in parentheses. 2r to the 0 power equals 1. But what about without parentheses? Do you know why that equals 2? Okay, let's go back to our negative exponents, and we're going to look at why and how we're going to write negative exponents. In this example, I have 6 squared divided by 6 to the 5th power. Well, when I go through and expand those out and start dividing, you see that I have 6 divided by 6, 6 divided by 6, but now I have 3 6s left in the bottom. So I actually have 1 over 6 to the 3rd power. So if you look at the rule, whenever I have a negative exponent, that means that needs to be written as a fraction. That base needs to be written as a fraction. So if I have a to the negative nth power, it actually is 1 over a to the n power. Okay? Okay, so let's look at these examples. If I have 3 to the negative 2 power, that means I actually have 3 squared in the denominator. 1 over 3 squared. If I have y to the negative 6th power, that equals 1 over y to the 6th power. And then the last one, my base is negative 2. So I still have negative 2 in my parentheses to the 3rd power written as a fraction. Okay, here are your 3 got it problems. They're also on your notes worksheet. Go ahead and solve them. The first one, x to the 10th power divided by x squared. The second one, write that in fraction form. What would x to the negative 5th power look like? And the third one is a little expression. Go ahead and solve that and tell me what you get for an answer. And we'll go over these tomorrow.